All right, so we're actually going to turn to page 26, and we're going to do lesson 5-7, and then we'll go back to the other sections in the same order as your notes after this lesson. So if you're not there, turn to page 26. This is lesson 5-7, roots and zeros. So we're going to determine the number and type of roots for a polynomial. So for this first one, consider the polynomial function. The zeros and roots of the function are -3, -2, 1, and 2. So then what were the factors? So if these are the zeros, then inside the parentheses, remember, it's basically opposite. So it's x plus 3, it's x plus 2, it is x minus 1, and it is x minus 2. So what are the x-intercepts of this graph? So here's one, -3, 0. Here's another one, -2, 0. Here's a third one, 1, 0. And then here's a fourth and final one at 2, 0. So for every polynomial equation with degree greater than 0, it has at least one root in the set of complex numbers. So this theorem doesn't seem like much, but it leads us to more important theorems here, which if it is x cubed, then we have 3 roots. If it is x to the 4th, then we have 4 roots. If it's x to the 5th, we have 5 roots. So the degree of the polynomial with one variable, this is the degree here, the largest exponent. So over here we've got some examples pointing to those zeros, which we've seen before in an earlier section. So if a polynomial has a degree of 3, it'll have 3 roots, places where the polynomial is at 0, and so on. So all we're going to do for this first one is just state the number of complex zeros each polynomial has. So here's the degree, 1. So how many zeros do we have? 1. Over here, squared, how many zeros? 2. So it matches that highest degree. So here's 5, should have 5 zeros. Over here, 4 should have 4 zeros. So for the last two, think about it. How many zeros would you have? Hopefully you put 2. And for the last one, 5. Not too hard, right? So let's take a look at the different types here. So using the fundamental theorem of algebra, we now know how many total zeros / roots a polynomial has. However, we need to keep in mind that there are different types of zeros and roots. There are rational. So for example, rational are the pretty answers, the roots that cross the x-axis and are easy to identify, like x equals 5, or even 1/2, or 0, or -2. Those are rational. Irrational are not as pretty, and they are not as easily identified. So maybe x equals plus or minus square root 5, x equals 4 plus or minus square root 3, or x equals 1 plus or minus 3 square root 6. And then we also could have some that are complex. These can be these can be sort of ugly answers because complex numbers include imaginary. So these are not always visible on the graph. The complex number system includes the rational and irrational. So a complex zero doesn't have to be ugly, but if it is only complex and not rational or irrational, then it will be an imaginary or ugly solution. So here, let's take a look at some examples. So we could have plus or minus 5i, imaginary. We could have x equals 4 plus or minus I square root 3, or maybe x equals 1 plus or minus 3i square root 6. So we also have to take a look at something called the conjugate. So only the sign in the middle is what's changing. So a conjugate is where you have that change in the middle of the binomial. And that is its imaginary part that the sign is changing on. So basically, if you have a root 2 square root 3, if that's a root, then you know -2 square root 3 is also, because we know it's plus or minus. 2 square root 3. So here's the positive. We also have the negative that is a root. So over here, if this is a root, which one do we change the sign on? Up in the middle. So it's 1 plus square root 5, which is also a root, because we know it's 1 plus or minus square root 5. So here's the negative. We have to represent the other one as well. So try these next two on your own, and then check when you are ready. All right, so let's go ahead and check. So if it's 7 plus 3i, then you should also represent 7 minus 3i. If it's negative 13i, then you should also have positive 13i represented as well. So let's go ahead and do some practicing. We are going to write all of the zeros, so finding all the additional ones that are not represented. So we basically just look for those imaginary or those ones that have the square root that have the sign. We also want to represent the other sign. So here we go. This one, 2 plus 3i, we want to represent 2 minus 3i as well. That one should also be in there. So over here, oh, there we go. We've got the plus. We also need to represent 3 minus square root 2. So on this next one, there's going to be 2 because there's an imaginary here and there's an imaginary, or not imaginary, but there's a radical there, complex number written there. So we want to represent both. So if this is negative, we should have a positive 7i. And then over here, this addition, we should also have subtraction. So both of those should be. Go ahead and try number 4 on your own and see how you do. Oops. All right, so let's check. So we should have not only positive radical 6, but negative radical 6. So anytime there's radical or imaginary, that's when we want to look to add that next, or that opposite. So 5 minus, we should have 5 plus 5i. Here, 4 plus radical 5, we should have 4 minus radical 5. All right. So this is basically rewriting the process of solving for zeros. Instead of getting a polynomial equation to solve, you'll be given the solutions and asked to come up with the original polynomial equations. So we have to remember our rational and irrational root theorems from above. If we are given only one of either type of root, we must remember the other one is implied. So let's go ahead. First step is going to be to set all given and implied roots equal to 0. Change it back into the parentheses, and then we're going to basically just multiply. Also, don't forget that I squared is negative 1. So let's take a look here. Setting each of these equal to x. Setting them back equal to 0, minus 3 equals 0, x plus 2 equals 0, x minus 5 equals 0. So now putting those in parentheses, x minus 3, x plus 2, and x minus 5. Now we can go ahead and FOIL these two. X squared minus 3x plus 2x minus 6, combining like terms. So it's x squared minus x minus, oops, looks like a plus now, minus 6. And then the next step and final step is to multiply. Again, we've got to bring down that x minus 5 because we just multiplied these two, is to multiply that last one and that third one. So you can use the box method if you want to. And we are going to take x squared and a negative x and a negative 6 times x and negative 5. So here's what we get if you kind of want to create that box. There we go. So it's x cubed, it's negative x squared, negative 6x, negative 5x squared, 5x, and positive 30. So combining like terms to get your final answer would be x cubed first, minus 6x squared, minus x, plus 30. All right, go ahead and try that next one on your own. Remember the I, I'll kind of help you out there with that 5 minus I. We also have 5 plus I, that's implied. So it should be x equals negative 3, x equals 5 minus I, and x equals 5 plus I. So actually, let's go ahead and just kind of finish this one together. So it's x plus 3 in parentheses. It is x minus 5 plus I, and it's x minus 5 minus I. So multiplying these two together, if we use the box method, I'm just going to go ahead and pull that up here so that you can see that. Page 28. Here we go. All right, so we've multiplied these two together using the box method. Remember, I squared is -1. And then where is the rest of it? Uh-oh. We didn't finish multiplying it by this, so we'll have to do that real quick, and then I will replay. All right. Nope, here it is. Okay, so we've got x squared. We have -5x and -5x to get -10x. We have a positive 25. So these are canceling out, and these are canceling out. So we end up here with minus a -1, which ends up becoming +1 added to the 25 to get the 26 here. So then we're going to take last box method here to take that x squared minus 10x plus 26 times x plus 3. And then we get our final answer down here of x cubed minus 7x squared minus 4x plus 78. So definitely want to get that one down to have an example with the imaginary numbers. Last one that we're going to do together, and then I'll have you finish up that last one, is going to be number 3. So let's take a look at that one. All right, so let's take a look at number 3 here. So we want to put x equal to 0, x equal to 3 plus square root of 2, and x equal to 3 minus square root of 2. Again, that we have the positive, it's just known that we also have its conjugate. So putting these back, we would subtract this from x, subtract this from x, and it looks like this. So foiling that out, we want to create the box, and we are going to have those parts cancel out here, and then we end up with negative square root of 4, which is really just -2 that you're going to add to the 9 here. So it's x squared minus 6x plus 7 when we combine those things. And then the last one is just that x from x equals 0. And then we distribute that to get our final answer here. So I want you to try this last one, follow what we did on 2 and 3, and definitely try and practice this last one. We're actually going to change it to make it a little bit easier. We're going to get rid of that 4. There we go. So just do negative square root of 5. Don't forget positive square root of 5. And then do positive 3i and negative 3i as your 4 zeros. And then go ahead and multiply. And then we'll check here in just a second. All right, so let's take a look at number 4. So negative square root 5, positive square root 5, positive 3i, and negative 3i. So remember that we want to get it to the other side by doing the opposite. So add radical 5, here subtract radical 5, here subtract 3i, here add 3i. So we're going to multiply these 4 things together. Here you can FOIL, here you can FOIL, making sure that you watch anything that cancels out, which we have that happen on both of those there. So it's x squared minus 5, because that's the square root of 25. Over here, x squared. This is an I squared that changes to -1. -9 times -1, positive 9. So it's x squared plus 9. So then we want to FOIL these things. You could create a box if you wanted to, and then simplify in the middle to get your final answer. So take your time, use the box method, watch your signs, and it's just going to take some practice.